Right, hello guys, my name is Minko. It is a great pleasure for me to be here. Today I'm going to be talking about the challenges in front of the single-page applications we develop. I have a few quick questions. How many of you are JavaScript developers? Awesome. How many of you have used Angular? Cool. And React? And familiar with Flux? Okay, only a few of you, then it might be interesting. So, a few words about me. I'm a freelancer. Right now I'm working with Learn Capital. We are changing education together. In my spare time I'm doing a lot of open source. I'm also blogging, writing since recently, and teaching at Sofia University and Hacker Schools in Bulgaria. In my spare time I'm trying to find time for organizing community events, Sofia Jazz and Beer Jazz Sofia. The social networks, you can find me on the links on the bottom left. I'm quite active at GitHub. So we're going to talk about the challenges in the modern web. So there are quite a few challenges, and we will be able to stop only on two of them. We're going to talk about scalability and performance. And in order to get better understanding of these problems and why they appeared, let's take a look at the past, at the deep, dark past, when Internet Explorer 6 was still bleeding edge, and when Justin Bieber wasn't on our TVs yet. So it's kind of far, far away. Everything was quite simple these days. We had our client, our server, Internet Explorer 6, of course. And the client was making a HTTP GET request in order to get an HTML page. The server was responding with some response. And after parsing the entire HTML content, the browser was starting fetching some reference resources, like mostly images. And in the end, we were seeing our awesome 90s page, which was usually looked something like that. And the raw JavaScript these days was quite limited. We were able to enter only a small piece of imperative logic in our pages, doing only some tweaks for eventually improved user experience. It was something like that. We had our 90s web page with these awesome shiny images. We were entering a little piece of JavaScript, for example, changing the background body to unicorn GIF and having our awesome effect. So, and we were happy. We were satisfying the needs of our users completely, and we were used to see only static resources which were linked together through hyperlinks. So having such interactions was awesome. However, over time, the requirements for the web changed. And the user had bigger expectations about our pages. They wanted better responsiveness, better performance, richer user experience. They wanted something like what the desktop user experience was. So they needed some dialogues, accordions, and whatever. And that's the time when jQuery appeared. All of you are familiar with jQuery, I guess. Basically, it provides us two main benefits. First of all, the cross-browser scripting these days wasn't pleasant at all, and it's not super pleasant nowadays as well. So jQuery provides an easy way by abstracting all the browser incompatibilities with FS8. They provided a very easy way for achieving the same things in the different browsers, no matter of how different they were, how different their DOM implementation was. And it also provided some internal DSL, something like internal domain-specific language inside JavaScript, which provided us to have bigger expressiveness and do more things with less typing. And jQuery, it came with one additional project, jQuery UI, which was even more awesome. We were able to have entire dialogue with only a single line of typing. Basically, jQuery UI provides a set of components, and you can reuse them in your application. And we started writing jQuery. So, yeah. But we didn't stop here, unfortunately. We started writing even more jQuery, and most of the time it was like copying code from Stack Overflow and pasting it in our code base. And there were quite weird things happening in our pages, like people were trying to do weird things with jQuery, like taking the sum of two numbers. Yeah, that was quite a common case. And we started writing a lot of jQuery spaghetti. As I said, we were just copying and pasting snippets from random places in our pages, and things weren't super awesome. They were getting bad. So they were getting very bad because we were scaling, but we weren't scaling the right way. We were just creating a huge amount of unmaintainable content, unmaintainable code base, which wasn't able to be further developed and debugged and wasn't scaling well. So what some people did was just to take a look at JavaScript, take a step back, and instead of write jQuery for summing numbers, just take a look at JavaScript and start thinking about a little bit more sophisticated things like architecture. The architecture, basically, maybe you're connecting it with the architecture of a building, but it is the complex or carefully designed structure of something, which could be the chemical structure of our brain, or it could be the front-end architecture of our application, or our back-end, or whatever. There was a little bit of misunderstanding where exactly the design of a system and the architecture of a system intersect, if they do. So Martin Fowler, in his enterprise patterns of enterprise application architecture, described the architecture as something as the decisions which are hard to change. So we are in the beginning of the development of our application, we are taking some decisions, some fundamental decisions, which are basically creating the base for our applications, and we are only developing on top of it. And that's how we can think of the architecture. One of the first guys in the JavaScript community who started talking about architecture, that was Nicholas Zakas. Maybe you've heard of it. He worked at Yahoo. Later, he moved to Box. So he developed his large-scale JavaScript architecture, application architecture, which was basically this thing here. It looks like a modular architecture. It looks like a layered architecture, and that's what basically it is. So we have our base library. We have our base library here, which could be jQuery, or it could be YY in the case of Yahoo, or Dojo, or Mutus, or whatever. We have our application core, which abstracts the base library through a set of adapters in order to make our application independent from the base library, and provides some additional functionality. Nowadays, this could be, for example, WebSockets, or APIs, or WebArtist APIs, or whatever. On top of the application core, we have the sandbox. And the sandbox knows only about the application core. It doesn't know about the base library, because we don't want to couple that much. So the sandbox, it provides all the interfaces which the application core provides, plus some primitives for registering, unregistering, and inter-module communication. Basically, these modules here, they don't know about each other. They know only about the sandbox. And once we register these modules into the sandbox, they're able to communicate together through event bus, some publish-subscribe pattern. For example, we can think of this architecture in the following way. This is my Twitter page. This is one module here, the tweet box. This is another module, and third module. That's, for example, fourth module. And these modules don't know about each other. They know only about the piece of DOM they are responsible for managing, and that's it. And for example, the tweet box here, when the user publishes something and press tweet, basically the tweet box throws an event. This event is being captured by another module which could not be visible on the screen. For example, some backend interaction module like our RESTful API. And the event is being captured. It is captured by front-end modules like this one, the tweet list. And they are handling this module. For example, the tweet list will add the tweet at the top. Basically, this architecture consists of decoupled modules which communicate together through an event bus. That's it. This architectural pattern is still popular in the JavaScript community. And Nicholas Zakas is doing everything to keep it alive. A little bit later, Backbone appeared. I bet you're familiar with Backbone. It's one of the most famous JavaScript frameworks. It wasn't the first one. However, it had very significant impact on the entire JavaScript environment. The development, the invention of Backbone was followed by the MV star fashion. First of all, I'm saying MV star because not all frameworks were MVC. There were MVVM, MVP, or MVC, well, we had different variations. That's why the Angular team entered the term MVW, which means model view whatever. And it was modern to develop your own MV style framework these days. And there were a lot of frameworks which appeared. Yeah, there were a lot of them. This is only like 2% of them maybe. Alius Mani developed an application called todomvc.com, which provides an example how you can develop to-do application using most of these libraries. Actually, some piece of them because they were developing quite often. And only a few of these libraries had significant impact onto the web. There were Backbone, Angular, Ember, Knockout, React, maybe Flights. And most of these frameworks, they were based on the same model. And that's the ModelViewController, or slight variation of the ModelViewController pattern. Basically, the ModelViewController, it was initially introduced in Smalltalk, and it is a software architectural pattern for developing user interface. And that's it. We have our model, our view, and the controller. So basically, our controller creates the views. The views delegate all user interactions to the controller. The controller changes, manipulates the model, and the model notifies the view about the changes in itself. Basically, when the user presses a button, we delegate handling this event to the controller manipulates the model, and when we change the model notifies the view about the change. There are different variations of this pattern, of course. A little bit later, the community just killed the controller. This happens twice, so at least twice. First, Backbone removed the controller from their implementation. Later, Angular in Angular 2, they removed the controller as well. They're arguing that they haven't removed the controller completely because they have different controllers associated with the different components. However, they don't have these ng controller-like floating controllers. However, all these frameworks, maybe except of React, they kept the same base, and that was the observer pattern. Are you familiar with the observer pattern? Awesome. Well, that's design pattern, not architectural, but design pattern, which was initially introduced by the Gang of Four in their book. So we can think of the design of the observer pattern this way. We have our user. Well, this might be a chat application. So we have chat application with different users. Somewhere on the screen, we are printing the username, and we have the list of users which we are communicating with. We have our class user with private names of type string and set name, which is responsible for setting the name, something like this. But what if we want to update the username onto the screen? Well, when we set the name, we can manipulate our DOM and change the contents to the name of the user. However, this creates troubles. Well, first of all, we are changing already existing code, and we are coupling our model, our business logic, with the structure of the HTML page, which is a bad thing. We can notify all the users on change of the username. For example, we can loop over all users and send notification about the change. But that's bad as well. We are coupling our model with all other users and the communication protocol and our application. What if we want to update the database? Well, that's not the right thing to do. We are violating the open close principle, which is one of the foundational principles in the object-oriented programming, which states that our software should be open for altering new functionality, but should be closed for changes. So what we can do instead is to use the observer pattern. Our user can maintain a list of observers, and when we want to change the username, we can just loop over all these observers and just call their update method. One of these observers is going to be responsible for setting the page for setting the DOM content, another one for notifying all other users, and the third one for updating the database, for example. However, this has two big pitfalls. We can think of these red dots as different modules in our application. We are changing one of these modules. It throws an event, so basically it calls its observers. Its observers change another module. Its observers change another module, and so on and so forth. So this is kind of a tangled data flow. We are creating very complex data flow, which is hard to follow and hard to reason about. There is one more problem here. So first of all, each of our modules, it has a state. And over time, this state changes. So this mutable state creates extra troubles. First of all, we have this complex data flow. And after all, we have our mutable state, which makes our application hard to reason about. What happened was that Flux was developed. Maybe you have heard about Flux. Basically, this was a front-end architectural pattern initially introduced in the context of the front-end from Facebook, which has almost nothing in common with MVC at first look. We have our view here, but I guess that's it. And the interesting thing in the Flux architectural pattern is that we have this unidirectional data flow. See how from the view we are going to the action, after that dispatcher, store, and view again. We don't have all these floating arrows anywhere. And describing Flux is out of the scope of the presentation. However, I'll definitely recommend you to take a look at it. It gives us two main benefits. First, enforces the unidirectional data flow, so we don't have the floating arrows. And it tries to keep our user interface as stateless as possible. This means that we are creating some immutable views, immutable components, which brings two benefits. So we have no more cascading updates and hidden dependencies like the first picture. And we don't have any more troubles for reasoning about the state, because we don't have state in our views. We have state as separate components. However, Flux is not a silver bullet. We are human. We make mistakes, like undefined is not a function. I bet all of us have had this mistake, have done this mistake. And JavaScript has some good parts, definitely. However, it is a dynamic language, and it has an unusual object-oriented model. That it is dynamic, it can be seen as benefit, actually, because, well, we like dynamic languages. They are very flexible. However, the object-oriented model, which is something like the object-oriented model in Cell for IO, it is, creates a lot of troubles for people who are experienced in Java or everything, actually, which is popular these days. So which language we should choose in order to make us more productive and less error prone? Well, the language should be easy to learn for sure. It should have better IDE and text editor supports. Maybe you are suffering from bad auto-completion in JavaScript and bad refactoring tools. And we should have a compiler which takes care of us. So when we misspell a property, the compiler will slap our hands and say, well, you did that wrong. So the requirements for our awesome language are these. We need to have statical typing in order to scale well. We need to have more powerful syntax, and it should be possibly a superset of JavaScript in order to make us learn it faster, allow us to learn it faster. However, adding new language in the browser is kind of impossible. Google tried this with Darts a couple of months ago, maybe. So they added virtual machine in Chrome for running Dart programs. They removed it later because it wasn't that popular and it made the complexity of Chrome grow. So what we can do instead is to have our awesome language on the left, we have JavaScript on the right, and we have this magic in between. This magic is called transpiler. So the transpiler can basically translate our awesome programs into the perfect world language to JavaScript. So this makes adding new language kind of possible. And there are a lot of languages which are aiming to fix JavaScript this way. Here are some of them. There are even more than the frameworks. However, we are going to talk about TypeScript. And TypeScript, it is statically typed. So we have compiler, we have better IDE and text editor support, better refactoring support. It is superset of ECMAScript, so it is easier to learn if we are already familiar with JavaScript. And it has some syntax sugar like classes, destructuring, and so on. So Flux plus TypeScript, this makes applications which are very easy to scale. Maybe we have a little bit more of typing in the beginning, but after that we scale pretty well. We should not, well, TypeScript is just an example. I'm recommending to choose some language which has long-term support, like TypeScript, which is developed by, which has solid base, which in the TypeScript case, this is Microsoft, and which is statically typed. Maybe I already said this. Well, you can also choose Elm, which scales pretty well with React as well. So let's talk about single-page applications now. Again, in single-page applications, we get all or nothing. This means that basically we have the same page, and since we are modern now, we have Chrome instead of Internet Explorer 6. We're making all these requests. We get our page, and after that, we need to run JavaScript. After we run the JavaScript on our page, and we discover which is the open view by the user, we need to make another set of requests in order to get all the templates and all the data required by the current view. So, and right after that, we have our awesome 21st century web page. But know that when we are running our JavaScript, we still have nothing onto the page. That makes a lot of troubles for search engine optimizations. So, search engines are usually not running JavaScript, maybe except Chrome nowadays. However, when they open our page, they see only this thing here. So they cannot index our content, right? There are a lot of tricks for doing this, but they're just workarounds. And also, the average web page size was 1.5 MB, and that was 2013. These days, the average page size is 2 MB, 161 kilobytes, which is a lot. I mean, and this was 1st of August. Maybe it's a little bit more, with a few kilobytes now. So we need to talk about performance, because on low-end mobile devices, we might wait for our single-page application to load for a couple of seconds, or even minutes if we are in the subway, for example, and we have poor 3G. So let's talk about the initial page performance. Which are the slowdowns in a single-page application? First of all, we have DNS lookup. We need to resolve the IP address from a domain name through UDP. After that, we need to establish TCP connection. So this involves a lot of things like the three-way handshake. It involves the TCP slow start. After that, we need to establish secure connection. We need to exchange a common secret. After that, we need to fetch all the resources required by our page, which includes blocking scripts. We need to parse all the JavaScript files. We need to bootstrap the application. We need to render the content. But where we can do something in order to improve our performance? Well, in DNS lookup, we can eventually improve it using some scripts, some tags which were actually DNS prefetch, which was added by HTML5. We can eventually improve the performance for establishing TCP connection if we are using CDNs. We can improve the fetching of our resources by minifying them, using concatenation, eventually using sprites, or HTTP 2.0 with server push. And we can use deferred script parsing for the blocking scripts. Let's take a look at how we can speed up the last 3 points. So what if I told you that your UI can live in the backend? This is something you're going to listen about a little bit later. What if the user can make a request to a single-page application with the single-page application URL? The server can parse this URL. It can invoke the JavaScript associated with the page, which is associated with the view, with the URL you're passing to the server. After running the JavaScript and fetching all the resources through some kind of XML HTTP request backend implementation, you can just render the entire user interface for the requested view, deserialize it from some backend implementation of the DOM, so serialize it to HTML and return it to the user. And later, the user can eventually add some event listeners to the server-generated content. So here is how it looks on the picture. First of all, we are doing all the familiar requests. After that, we are running JavaScript. And once we need to run JavaScript, we already have our view rendered, which is awesome. So it can be indexed by search engines, and the user will see the view much faster. However, we need to add all the event listeners required for the view, of course. And this is called server-side rendering, and it is super awesome. You can use it today. Server-side rendering, it gives us a lot of benefits. 2 of them are SEO-friendly applications and improved user experience. So you can use it today. You can use it with Angular. Patrick and Jeff from the Angular community, they developed a thing called Universal. It lives in the Angular organization. You can take a look at it. It will have soon some Scala server-side renderer. I think it works with Node now. React, it is not a new thing in React. It works in React for the last couple of months or even year. So you can use it there as well. here are some of the resources you can take a look at. I'll definitely recommend you to take a look at Flux because it definitely creates application architectures which scale. You can do that. You can take a look at the Flux in-depth series. Take a look at TypeScript, Angular 2, because it's going to be super awesome. React server-side rendering, Angular 2 server-side rendering, and yeah, that's it. Thank you very much for your attention. Yeah, if you have any questions, I would love to try to answer them.
Okay, so what do you think about Relay from Facebook or Falcon from Netflix? Have you ever heard?
Yeah, it is going to have awesome integration with Angular. It was introduced maybe a year ago by Netflix, I think on ng.com, but I'm not completely sure. Jafar from Netflix talks about it on every next conference, so I see it's something like GraphQL, but I hope better because I'm a fan of Angular. Yeah. With Angular?
I'm asking about Sophia.
Sophia. Yeah. Yeah, we have Facebook group. We have also Twitter account. The Sophia JavaScript is a Twitter account. So you can join the group eventually. We have only offline events, yeah, so far. So only offline, only on site.
So correct me if I'm wrong, your specialization is AngularJS, yes?
Yeah, well, recently I'm using mostly React, but
yeah, great. So nowadays, modern frameworks, Ember, React use virtual DOM, and in latest release of React, they even separated virtual DOM and everything else. Does Angular work with?
No, they use dirty checking, but they have isolated they have decoupled the entire framework from the DOM, so they are able to run the dirty checking into different threads using web workers. So they still bet on dirty checking. However, they have very sophisticated implementation right now. And using immutable data structures, they're doing some benchmarks, but it might run even a little bit slightly faster compared to the virtual DOM in React. But this might be speculative. Yeah, on a lot of things, yeah. Yeah.
So you started your presentation from server-side rendering, and you finished again with server-side rendering only with JavaScript, right? What is
Initially, I mostly want to explain how everything starts with just simple HTTP requests to the server. By default, there is server-side rendering in the traditional web applications. The first part was mostly about scaling, and I believe that Flux allows to scale pretty well. Yeah.
What about supporting TypeScript, ECMAScript 6?
TypeScript. It evolved quite a lot after Angular started using it. It supports ECMAScript 2015 and 2016 with the decorators. However, TypeScript added a little bit extra features on top of decorators. You're able to annotate the individual parameters in your functions, for example. TypeScript also supports JSX, since actually it doesn't support it yet. It supports it better like 1.6. But you can develop React applications with TSX files and include inline like JSX inside your files. Yeah, it's a little bit more of typing because of the static typing. You need to define the interfaces of all the properties which your component accepts, and yeah.
Thank you for your presentation. My question is, are you using any code metrics to restrict yourself? Well, I believe you're working alone on the project, right? Or you're working in a group, and are you using any metrics to find
yeah, mostly kind of, they're kind of, well, initially I started a large-scale project, which is about, well, not that huge, but about 20,000 lines of code with Angular 1. And this complex data flow definitely, well, basically, when Facebook introduced Flux, they were talking about exactly about this, how they can improve the data flow in their applications, how they fix the immutable view in their chat. So this implicit dependencies and this cascading updates and all this complex data flow creates a lot of bugs, definitely. However, since recently I'm using Flux with React, since recently maybe for a year and a half, and Flux is not coupled with any framework. You can use it with Angular 1, 2, Backbone, whatever you choose. And definitely I've improved the code readability eventually. And for sure I have much less bugs. That's just kind of just felt it from the bug reports from the users.